All right, let's dive right into this explainer and demystify the complex engineering behind one of the most talked about phenomena in tech today. We're talking about how we detect and fix AI hallucinations. Look, if you've spent any time at all working with large language models, you know that they can be incredibly articulate, but they also have a nasty habit of confidently making things up. Today, we aren't just going to look at why that happens. We are going to unpack the cutting-edge timeline of interventions that engineers are actively building to keep these models grounded in the truth.
To understand why this matters so much, you have to hear this shockingly low number. Researchers evaluating long-form text generation found that even highly advanced models like ChatGPT only hit a 58% factual precision score. 58%! They used a metric called FActScore, which breaks down text into verifiable atomic facts, and found that when generating complex long-form content, models really struggle to stay completely factual. For anyone relying on AI for research, coding, or critical business tasks, a coin flip on factual precision just isn't going to cut it.
So, here is our roadmap for today. First, 1, the AI hallucination problem. Then, 2, prompting and guiding the input. Next, 3, inside the model's brain, followed by 4, post-generation fact-checking. And finally, 5, keeping humans in the loop. Okay, kicking things off with Section 1, the AI hallucination problem. First things first, we need to understand our central villain. An AI hallucination isn't the machine maliciously lying to you. By definition, it's the generation of highly plausible but completely ungrounded or false information. The text is perfectly grammatical, the tone is super confident, and it sounds entirely reasonable, but it just contradicts the facts. The model is essentially connecting linguistic dots, but totally failing to tether them to reality. So why does this happen? Well, there are 4 root causes driving this behavior. First, insufficient training data. The model simply hasn't seen enough diverse information to make accurate correlations. Second, model overfitting. This is when the AI essentially memorizes its training data, but it can't adapt correctly to new unseen prompts. Third, inadequate supervision means the model is relying way too much on its own internal logic without proper guardrails. And fourth, the knowledge cutoff. The model literally doesn't know about events that happened after its training wrapped up, so it just guesses.
Moving right along to Section 2, prompting, guiding the input. This is our very first intervention point, fixing things before the model even has a chance to hallucinate. And the most foundational fix here is Retrieval-Augmented Generation, or RAG. Think of a standard closed-book LLM as a student taking a test purely from memory. If they blank on the answer, they guess. RAG turns this into an open-book test. When you ask a question, a retriever first searches an external, up-to-date knowledge base, grabs relevant documents, and hands them to the generator alongside your prompt. It gives the AI verified facts to draw from, which drastically reduces the need to invent information. Another super fascinating pre-generation technique is chain verification, or COVE. Think of it as the AI taking a deep breath to plan out and double-check its own math before handing in the final test. First, it generates a baseline response. Then it actively plans out verification questions to fact-check its own claims. Crucially, the model answers these verification questions independently without even looking at its original response, so its own biases don't creep in. Finally, it uses those verified answers to generate a corrected final response. It's so clever. All right, let's get into Section 3, inside the model's brain. This is where things get really sci-fi, because we can actually intervene during the generation process, right inside the model's architecture, token by token. One method here is active validation. As the model types out text, it monitors its own uncertainty metrics. If it senses low confidence about a specific fact, it literally hits pause, generates validation questions on the fly, answers them to correct itself, and then keeps going. Researchers found that by actively validating low-confidence text in real time, they could detect 88% of potential hallucinations and mitigate over 57% of them instantly. Another inside-the-brain method is a strategy called DoLa. This leverages a wild architectural quirk of transformer models. You see, an AI's basic linguistic instincts, like just knowing how to string words together, live in the early, premature layers of its neural network. But its factual maturity, its actual knowledge of the real world, lives in the later, mature layers. So if you ask for the capital of Washington State, the premature layers might scream Seattle because those words are commonly linked, but the mature layers actually know the factual answer is Olympia. DLA capitalizes on this by calculating the difference, specifically the Jensen-Shannon divergence, between these layers for every single word it generates.
In plain English, it dynamically contrasts the layers to amplify factual knowledge and actively suppress generic linguistic guessing. And it does this mathematically, without any extra training. The result? It significantly reduces hallucinations, improving performance by up to 17% on benchmarks like Truthful QA.
Okay, moving to Section 4, Post-Generation Fact-Checking. This is our third checkpoint. The AI has generated the output, and now we need to grade it and verify what it actually produced. Engineers use a whole toolkit at this stage. First, SelfCheckGPT literally asks the model the same question multiple times. If the answers are consistent, it's likely factual. If they're all over the place, it's hallucinating. Then we have FActScore, which rigorously decomposes long text into single, atom-sized facts and checks them against a database. And finally, GEval uses chain-of-thought prompting to force an evaluator AI to explicitly write out its reasoning, mimicking how a human would grade the text's factual consistency.
Finally, Section 5, Keeping Humans in the Loop.
Because here is the harsh reality. Even with perfect RAG setups, dynamic layer contrasting, and post-generation grading, there's still one massive vulnerability in the timeline. What happens if the error doesn't start with the model, but with a mismatch between what you asked and how the data is stored? If your question is ambiguous, the model can't retrieve the right documents. And when it can't find the documents, it's going to try to guess, leading us right back to our central villain, hallucinations.
That is exactly where an interactive framework called Mixalign comes in. Mixalign tackles this in 2 steps. First, model-based alignment uses an LLM to actively rewrite your prompt to match the database structure. But if the query is still ambiguous, like maybe the database needs a specific season but you just asked about the weather, it triggers human-assisted alignment. It actually stops the generation process entirely and asks you, the user, a clarifying question. Your human answer then guides the final retrieval. By simply keeping a human in the loop for a fraction of a second to clarify intent, the results are absolutely staggering. Mixalign's interactive framework yields a 22.2% improvement in overall model performance and drops hallucinations by an incredible 27.1%. It proves that sometimes the absolute best engineering fix is simply stopping to ask for a little human clarification. Which leaves us with a fascinating question to ponder. We've seen how researchers are building brilliant automated timelines to truth, from retrieving documents with RAG to mathematically contrasting neural layers with DoLa, all the way to grading output with FActScore. But as we engineer these models to become ever more adept at self-correction, will AI ever entirely outgrow its need for us? Or will human context and intuition always remain the ultimate fact-checker in the loop? Definitely something to think about the next time a chatbot gives you a surprisingly confident answer.